Now we're going to take a look at how to evaluate limits at infinity for more complex functions using the rules that we just learned for different x to the n, 1 over x to the n, and constants. Okay, so example 1, limit as x approaches infinity of 20x squared minus 3x, the numerator, divided by the denominator, 3x to the 5th minus 4x squared plus 5. So all we really need to do is kind of look at each of these components. Follow these steps that I teach you and know those rules that we looked at before. You're going to get the right answer every time. Step 1 is to determine the largest power in the denominator. So we're looking down here. So obviously the highest power is 5. I'm going to write the largest power as x to the 5th. So it's not just the exponent, it's the base as well. So it's x to the 5th. Okay. Step 2 is to divide the numerator and the denominator by this power you just determined. So I'm going to take the numerator and divide by x to the 5th. I'm going to take the denominator and divide by x to the 5th. Okay, now the next step is going to be just to distribute this x to the 5th to each term, and both on the top and to the bottom. So that's part of step 3, which is to simplify. And anytime I just have an x, I'm going to write it as x to the 1st. And that's pretty much all I've done, is just distribute that x to the 5th. Now, in order to simplify that, I'm going to need to know that if you divide two powers, I need to know the rules, right? So for example, I have an x to the 5th on bottom, x squared to the top. That's going to become x cubed on bottom because 5 is bigger than 2. X to the 5th and x to the 1st on top, it's going to become x to the 4th on bottom. Notice nothing happens to the constants. Here the x to the 5ths cancel, and it's just 3. Here 5 is bigger than 2, so I put an x cubed on bottom, and then nothing here. So again, this is just part of step 3. Which is to simplify. So that's actually as simple as it's going to get. Now I can just use those limit laws to go ahead and evaluate. So step 4 is to evaluate the individual. I need to move that so you can see, or let's just make it smaller. Alright, step 4 is to evaluate the individual limits. So now that I've simplified my expression into a bunch of different fractions after dividing by that largest power, I can now plug in infinity for x. And we know our limits as x approaches infinity of, say, 1 over x cubed or 1 over x to the 5th. You can also kind of do this intuitively even if you don't know those rules. But anyway, basically we're plugging in infinity for x. So let's look at the first one. We have 20 over infinity cubed. So this applies to the rule that we learned about 1 over x to the n, right? It's going to approach 0. But why is that? Well, you're taking 20 and dividing by a really, really big number, so it's going to approach 0. So the limit as x approaches infinity is going to be 0. Same thing for this one. This is these numbers up here don't matter, right? Because they're so small as compared to infinity, they don't matter. So 3 over infinity the 4th is going to become 3 over infinity, which is a really small number. It's just going to be 0. Now this is a constant number, so it's going to remain 3. I mean, there's no infinity to plug in right there. Then we have, again, 4 over infinity cubed, which is just, again, 0. You can think of this also as 4 times 1 over infinity cubed. So 4 times 1 over x cubed as the limit as x approaches infinity is going to be 1 times 0, which is 0. Same thing for this one, that also turns to 0. Again, you're just dividing by a huge number, so this is going to approach 0. So now we have all these numbers. The top is going to become 0, the bottom is going to become 3. And 0 divided by 3 is 0. So for step 5, you just evaluate the limit. Once you figure out those individual limits, then you just divide 0 over 3, and you get 0. Therefore, the final answer, limit as x approaches infinity of 20x cubed minus 3x over 3x to the 5th minus 4x squared plus 5 is equal to 0. Okay, so here we have our function. We're going to put a point on the function. Here's our function, 20x cubed minus 3x over 3x to the 5th minus 4x squared plus 5. We can see that it indeed, as x approaches infinity, the y value approaches 0. We can also see that if we were to ask about negative infinity, it would also approach 0. But we were concerned about positive infinity, and the y value approaches 0. Before I ended, I just wanted to go back and explain this one more time, just because I felt like I need to show at least one more step for one of these. When you have a constant over like n x to the n, for example, this would be x cubed, so n would be 3. Again, you can basically imagine this as pulling the 20 out and writing as 20 times 1 over x cubed, and then pulling that 20 out even further outside of the limit. So what would happen is you'd get 20 times the limit as x approaches infinity of 1 over x cubed, which we proved with this, let's get back up here, limit law that 1 over x cubed, limit as x approaches infinity, is 0. So basically what you'd have is you'd have 20 outside here. You can pull the 20 out because that's a constant multiple for limits. 20 times 0, which turns to 0. So my point about, see, these numbers on the numerator don't matter. All that matters is that you have an infinity to the n power on the bottom. And that's going to be true for any of these examples. Anytime you have some constant number that has nothing to do with the power of the exponent, it's not going to affect the limit because you're comparing infinity to something much, much smaller. Alright folks, so that's it for this example. If you have any other questions about it, let me know.